Did you know that every time you order food, book a ride, or even check who's viewed your LinkedIn profile, powerful real-time analytic engines are making it happen in milliseconds? Do you ever wonder what it takes to really run those platforms? Apache Pinot does just that, handling billions of queries every week from the top web platforms in existence. In this episode of Great Things with Great Tech, I'm joined by Kishore Gopalakrishna, CEO and co-founder of StarTree, to explore how real-time analytics is reshaping entire industries, powering next-generation AI agents, and transforming observability. In the age of data and AI, it's never been more important to access, process, and leverage data in real time. This is episode 97 of Great Things with Great Tech with StarTree. Hey Kishore, welcome to the show, and thanks for joining. It's a great time to be talking about real-time data analytics, as I said in my intro. Before we get into StarTree and everything that you've done, it's a great journey. But let's go back in time to start about that journey and what got you into computing. Where were your early days? I believe you're from Bangalore. Just give us a little bit about yourself as a bit of a background. Hey, you ended up in the States working for LinkedIn and now founding a really innovative company in real-time data analytics.
That's awesome. Thank you so much, Anthony, for having me on the show. It's a pleasure. I think if I had to talk about how I got to US, I think that itself will be another episode. But I'll keep that really short. I mean, it's my wife now, but then my girlfriend. She was studying or doing a master's here. So that's kind of what really got me to US. And what got me into computer science, I think that's another story by itself, but it's really gaming. So back in college, I really got excited about gaming. I'm electrical by background, but I got so excited with gaming that I started building some of these games, and that's kind of what got me excited into programming.
Okay.
So that's even though I didn't do my computer science, that got me excited into coding and learning about all the different coding languages.
That's interesting.
Go ahead.
What sort of games? So what games? Number one, I love gaming.
You'll probably guess my age by talking
well,
about.
I think we're almost the same, right? But yeah, let's play that. Let's play that game. Tell me the game, and I'll guess your age.
Yeah. So this is Pac-Man and Paratroopers and Tetris and games like that. So
yeah, excellent.
Just the 2D DOS games that you would build, and I think these were the times where NFS, Need for Speed, and all those things, other things were also very popular.
Oh, how good!
Then Half-Life, those
Speaking.
Kinds of,
yeah. Half-Life is still. I still play Half-Life. Actually, I don't know if this is a very, very quick side note because it's interesting. The RTX edition of Half-Life 2 came out last week, which was the enhanced NVIDIA version with all the beautiful graphics, and so I'm actually playing it again. It feels like a different game with like beautiful, sort of still the same graphics, but all the AI innovation that NVIDIA brings into their RTX technology just brings it. It's crazy. It's crazy good. I recommend it if you want to get back into it and have some fun, go there.
No, I don't think I can. If I
too much time.
I don't
get sucked in.
Yes, too much time. I'm a big time into gaming again, but yeah, I can't really afford that right now.
Of course, we've got busier things to do, isn't it? Sad how we kind of give up a little bit of those things? But that sent you off. So you started to code these games. You obviously had an interest in it. And then, from the point of view of going to university, again, did you do computer science or anything, or engineering, you said?
No, it's just from there, I directly got into jobs, and I started off with Oracle in India. And then when I came to US, I started off with at Yahoo. I think that's where I really got interested in distributed systems. I was working in the Hadoop projects and then Zookeeper and all these other systems. And to me, the distributed system concept itself got me really excited. And I think it's especially the part where, it's kind of Leslie Lamport quote, which says like a distributed systems is one where you kind of machine that one machine failing renders completely another machine useless, right? Which is very interesting. And that's kind of what got me interested in distributed systems, because there's so many ways a system can actually fail. And the fact that you have to design a system that handles all these failures and yet still be functional, was a pretty big challenge. And I saw it from outside when Hadoop was happening. I didn't really work on those systems, but that's kind of what got me excited and really wanted to build a distributed system from scratch to understand all these things. And then I got to LinkedIn, and that's where got the opportunity to build the systems from ground up. And Espresso was the first system. This is like a MongoDB equivalent, NoSQL data store that we built at LinkedIn. We built a cluster management framework as part of that called Apache Helix, which allows you to build a lot more distributed systems very easily so that you don't have to worry about all the fault tolerance part.
Yeah.
And from then I got an opportunity to build Apache Pinot. I think this was a very interesting challenge that we had at LinkedIn, where we as a company wanted to provide insights to millions and hundreds of millions of LinkedIn users. Right? I think that was the first time a company embarked on this kind of a mission to say like, hey, analytics should not be restricted to just the people within LinkedIn. Why can't we show this to our users? And I think that was a big hit where they were, when you saw who viewed my profile on LinkedIn, I think that was the flagship project where we started this, where we said like, hey, just give them the insights on who is viewing their profile. And something which is as simple as that was a big success at LinkedIn. A lot of people started saying, hey, I see this profile. I worked with him. I worked with him at this company. He's from my college. And then all of a sudden, the number of connections started increasing. So there were a lot of these second order effects. And that's kind of what led to a creation of Apache Pinot.
That's interesting. Yeah. So, a lot of necessity in these projects inside of the Yahoos and LinkedIn's obviously have led to such systems being built. And interesting that you build it internally. And then also, for me, it's interesting that, it's all sort of, there's a lot of Apache here, a lot of open source and stuff. Is that how it started within? Like, was that always the idea when you're building these things within these organizations to, do you build them to only benefit internally to start with? And then at what point does a decision become where you want to then say open it up in an Apache license and whatnot? I'm very intrigued with that, obviously.
Yeah, actually, that's a great point. And I think every company has a different reason for open sourcing. And I think LinkedIn was one of the best I've seen. I think what we realized, there was an open source committee back in LinkedIn as well, and I was a part of that. And what we found was actually promoting open source culture actually had a lot of benefits. I mean, one, the project itself would be really good because you're now writing a lot of documentation. You're making sure that your code is actually seen by hundreds of thousands of developer outside. So you actually focus on the quality of the code, documentation, and everything else. And the second part is also on the hiring. So you actually end up attracting the best talent. So while one way of thinking is like, hey, why are we giving this software away for free for other companies to use? But the second order effects of open sourcing is very, very high. And I think that's something that LinkedIn understood very early on. And we almost had the mantra internally, like, hey, why are we not open sourcing this versus why are we open sourcing it? So I think it was a great, especially for a developer, it's great to see something like that where you're constantly promoting open source. I think there was a great analogy. I think one of the VPs back at LinkedIn who used to say is like, it's like how you keep your house when the guests come in. Right? Open source is equivalent to that. Right? It's like you always tidy up your house, make sure that it's the best version of the house that you're presenting when a guest. So open source is equivalent to that, and we kind of saw it firsthand. And when we asked a developer to open source it, they would actually just go out and clean up all the things, write the proper documentation, comment the code, recipes. I think it just had a lot of benefits. So I think it's always good. I think a lot of people think about open source as, hey, why are we doing this? Who is it going to benefit? But it's actually the company that's doing it is going to get the maximum benefit.
That's really interesting. I think interesting point about attracting a certain type of talent as well to feed that at the same time. And I think also what I see, or what I think I see from that response and the second order effects, is that you're also going to get really good talent because you see them working openly from this pool of talent that you wouldn't have access to. And then if you're on that committee or if you're looking at the contributions, you're then able to see exactly, who's good, who's not, and kind of weed that through. So I think that's really interesting.
That's true.
Yeah, and I think the analogy of the house and the guest is interesting because I would have thought of it the other way. Well, the impact of inviting guests into your house is that it creates dirt and mess and chaos and you're busy. Does that happen as well? Is that
Yes, it does.
unavoidable part of that?
It's actually a great part of that, right? Because now because when you open source something, people are using it in ways that you had never thought about, right? I mean, that's one of the things that we saw. And when they do that, they stumble upon bugs and gaps and friction and other things that you had never anticipated. So in a way, it's actually making it better and better. You're getting more testing, more coverage. And at the same time, it's actually turning that into a system that is actually versatile and able to do many more things than what you actually started with.
Yeah, amazing there. So within LinkedIn, obviously, Pinot came around, real-time analytics for, was it as basic as who's viewed your profile? Is that effectively where it started from as a solution for that?
It's just as simple as that, right? I think one of the things that happened, I mean, our first solution was based on something like Elasticsearch, right? The thing that really forced us to build something else was the concurrency part of it, and which is really having hundreds and millions of people accessing this at the same point. And you believe it or not, the size of the cluster was 1,000 nodes for who viewed my profile when we had the search system. And that's where the cost of that cluster was very high and the maintenance was also very high. And that's when we said, like, hey, let's figure out what it takes to build an efficient system to serve this kind of a use case where we can provide the freshest analytics on lots of data coming in streaming, as well as to millions and millions of users without compromising the latency. I think that in short, like freshness, concurrency, and latency, I think those are the three key things that we wanted to solve all at once. And once we built this, we came down from 1,000 nodes to like 75 nodes with the traffic growing 5x. So overall, like a 50x improvement. And that's kind of changed the mindset in LinkedIn. And we said, like, hey, we should be doing this for every vertical that we have. Why are we just restricting it to who viewed my profile? What if we show analytics on every article someone posts? So if you post an article, you will get a lot of detailed insights on that. If you post a job, you get that. You post an ad, you get that. So it's like, it just became like a de facto thing that every page or every entity, if you think about it in LinkedIn, ends up having analytics associated with that, right? And
yeah, you don't think about that, right? Like I think a lot more, 99.9% of the people who would go on LinkedIn do not understand exactly what it takes to see that little, marker down there from a metrics perspective, who's viewed your profile. I think it's crazy to think that there's like 1,000 servers. Because my background is hosting, right? So I know all about that hosting game, and to think that you would have had to sit there and do 1,000 servers, 1,000 nodes for that one particular, feature. It blows my mind in that sort of scale. It's just a completely different scale. But out of that, that's the necessity. That's where you go. How can we make this better? How can we make it more efficient? How can we, if we're going to scale this to 50 million, 100, 200 million, even 1 billion users, like how are we going to make that? It's at a different level. And it's a really interesting insight, not only into how StarTree came about, but also that world a little bit. So let's talk about, the step now to StarTree, because in 2015, Pinot was open source, start from roughly. And then there's a donation that happens. I think a lot of people you hear about it, donation to the Apache Foundation. What does that mean? And then from the part of Pinot, what impact did that have when you donate it to such an organization?
Yeah, I mean, ASF is, again, people confuse ASF to open source. I think ASF is a lot more than just open source, right? Open source is just putting it on GitHub and making it public. But I think I think the mantra there is community over code, right? It's not just about the code that you're actually putting it out there. Is there a community behind that, right? So because the life of this project is now beyond the creators. So you're almost, even though we are kind of the creators and the co-authors of the project, the idea is that, hey, this is a project that can continue even after the creators actually are not invested in that. So that's kind of what ASF provides. It kind of has the governance model behind it, make sure that everything is done in the right way. So I think that's the benefit of ASF, and I've been involved with a lot of ASF projects before as well. And I think now the ASF was the one that used to provide that kind of guidance. But I think now people can get the same without being part of the ASF. It's just because there is so much knowledge and in terms of what it really takes to build a strong community around a project. So ASF is not a must right now, but still one of the best organizations out there, foundations out there.
Understand. That's really interesting. Yeah, it's always interesting to ask that question, understand the psyche and the mechanisms behind that. So once that's done, late 2019, you decided to step out, as all good sort of founders and entrepreneurs do, with a co-founder, and you look to commercialize Pinot. So how did that go about? So where's the mental step in terms of the justification? Donation, you've worked on it, and now you think we can actually create a company around this?
Yeah. So, I mean, as soon as we open source, Uber was a big adopter as well. I mean, all the apps that you see, either Uber Eats or if you're taking a Uber ride, a lot of numbers that you see on those apps are all being powered by Pinot as well. So Uber was the next company that took this technology, did massive number of projects which are very, very innovative. I mean, think about a restaurant owner getting analytics in real time, right? I think that's an amazing story by itself when seeing like what kind of change such a technology can bring in this industry. So that's kind of when I realized that, hey, more and more companies should be doing this, because by then Kafka had become, by 2019, 20, Kafka had become prominent. Every company pretty much had it. But when I really looked at the usage of Kafka, most of them would have Kafka, but then they would get the streaming data, but then they would just put it in the data lake. So that was kind of defeating the purpose of why we built Kafka in the first place back at LinkedIn, which is to really say like, hey, you can go from an event to an insight within seconds. That's the real purpose of it, because there is so much of value in an event as soon as it occurs. You search for a pizza, the value of that event is the highest right now. I mean, if you try to act on that one day later, there's not much value in that, right? I mean, if you know that you're searching for pizza right now, I can suggest the right restaurants to you. I can send you discount coupons. So but if you don't, then it's like, yeah, even if it is 5-10 minutes later, you're already ordered it, and you probably
so needs to be instant. No, that's a really good analogy to think about the use case. Yeah.
So I think that's how Uber was able to leverage this, and then same with LinkedIn as well. But what we realized was a lot of companies should be doing it, but they're not, because they're, again, even though they have Kafka, they're just putting it in the data lake, and then they have this latency, which is, it's going to take hours or even days to actually get insights out of that. That's why we started StarTree. We believe that many other companies should actually be doing the same, because they're already collecting massive amount of data. And if they can get insights on that in real time, then they can either do one of the two things. One, definitely they can provide more insights to their customers and help them make better decisions, or they can actually use this to save money, because they can detect problems early on. And they don't have to wait. Like, think about experimentation, for example. A lot of times people try experiments, but if you don't know that because you tried an experiment, some metric is going down, then you probably lost one day's worth of revenue or something along those lines. But if you know that, you can immediately turn off the experiment and then make sure that you don't have the loss. Again, experimentation is one, but you can think of system issues.
That's good. Yeah. Two different use. You've obviously started at the consumer sort of front end. Let's understand the end user who's clicking on the application, make money there. But then you've really talked about that other use case, or a couple of use cases, to actually help be more efficient in whatever enterprise you're doing at that point as well. So there's two different use cases for the real time.
Different use cases, but interestingly, it can be on the same data. Like, for example, think about Uber Eats, right? It is just the order information that's coming in, and then like how many orders are getting served and how long is it taking and etc. But now there are so many parties that can actually use this data in different ways, right? For example, a restaurant owner is just looking at his or her own restaurant's data and then saying, hey, what is happening to my order time? Is it going up or is it going down? And then they can make a decision of hiring more people if they're taking a lot longer to serve that order. The same data is being used by us consumers to make a decision because we want the order to come very soon. So we are looking at the number on Uber Eats and saying, hey, is this restaurant taking too long? So we are making a decision on that. But now you think about the same data of operator setting within Uber. Now they're looking at an aggregate level. So now they can see like, if within this zip code or within this area, what is the supply and demand that's happening? So if there is less demand, can we actually send out more coupons so that more people actually order? Or if there is too much demand, can we shrink the number of restaurants that we show? So there is exactly the same data, but you can actually think of so many different use cases.
Yeah.
One is trying to make money, the other one is trying to save money. So it's
still
fascinating.
net the same result, right? Dollars go up at the end of the day.
Yeah.
Before we get into StarTree, again, we've talked about this without really getting into the founding, but I think it's what's really great here is my understanding of this world of real-time data analytics and the more distributed systems versus what people would think about. You mentioned MongoDB earlier, MS SQL, Oracle, the traditional relational databases, right? Why are they? Is it just the high availability and distribution of those systems that makes them not great for this use case? Or is there more to it in that? I'm not sure if that's a long answer, but
well, I think there is a short answer for that. Yes, you can have a really, really long answer for that, but I think it starts from the row store versus columnar store. I think that's a classic difference between your OLTP stores versus OLAP store, and that's been there for very, very long. I don't think that's new. I mean, all these databases existed, Vertica and all these columnar databases existed for a long time. I think it's the rise of SSDs that actually allowed us to build a different architecture for the OLAP systems. So you don't have to, because you're no longer limited by the disk and you have SSD systems, you can actually do a lot of random access and you don't have to completely rely on sequential access. That allowed us to think differently in terms of how these systems are architected. MongoDB and all these other OLTP systems cannot really do that because they are row-oriented. That means if you ask for one particular column, they have to read all the columns. You cannot really read just one column that is actually needed in the query. So it's really how much it boils down to. All these systems boil down to the work done per query. So and the work done is not really just the latency that you are serving, but it's the actual work done in terms of the amount of data you need to read and the amount of CPU you're actually using. And columnar databases allow you to read very little data that is only needed for the query, versus the OLTP systems read a lot of garbage and they have to filter it out.
Interesting. Okay, great analogy. That's really good. That's actually good because I think a lot of people that are not obviously natively in this world kind of want to understand a little bit about what the difference is. That's a really good way to do it. Okay, so StarTree. So talk through the founding, the name. I'm always interested in the name of the company and how that came about. I've got a little bit of an idea given stars and whatnot, but talk about StarTree and the founding and then the name.
Yeah, no, absolutely. As I mentioned, that the reason for us to start was there are a lot of companies that should be doing the same, and one way for us was to bring this to the masses is to start a company, make sure that there is great support and innovation that continues on Pinot beyond LinkedIn and Uber companies, right? And the second part, in terms of the name, this is interesting because I think we had a different name before we launched the company. But then before the launch, we wanted to come up with something. And one of the options for us was based on the indexes that we have. I think Pinot is really known for the speed at which it can serve queries. And one of the popular indexes in Pinot has a ton of indexes, the index for every possible workload that you can think of. And StarTree index was something that is very special. It allows it's one of those things that people, wow, is this real? Is this query really returning the right answer? Because they suddenly go from like 30 seconds to 40 seconds to like few milliseconds in terms of
Yeah.
the query latency. And that's why we picked the name based on the StarTree index, which is one of the most powerful indexes in Pinot.
Wow. Okay. There you go. Yeah, it makes sense, right? So it's a name based out of a really cool functionality and feature in the product. I love that.
Yeah,
Cool.
yeah.
And it makes sense. And then what's also interesting is that, so again, late 2019, the company started. Obviously, and we talked about this a little bit in the pre-show. Yeah, that we don't talk about the dark days of COVID much anymore because we kind of forget that it happened.
Yes.
It must have been really interesting to start a company at the end of 2019 and have all that positivity and that push, and then to have it sort of probably just squashed a little bit, by 3 or 4 months later. So very briefly, like what was it like to start a company around that time, and how did you really push through?
It was scary, frankly. I think it's something that I never expected because we have been used to like starting companies where everybody coming to office, and especially in a startup where you're like just few people and you want to meet every day and you want to move very fast.
Yeah.
And all of a sudden you're like, hey, you can't first of all meet your team members, and second, you're starting a company and you're supposed to sell. And talk to customers, and no one, you're not able to meet anyone, and then all of a sudden it's like, yeah, how do I figure out how to sell a product over Zoom, and then how do you even make this happen? So there's so many unknowns that I think it was a scary situation, and I think we had to make some tough choices in terms of where we hire, how we actually get to the next step, and what kind of a bar we need to put in terms of our hiring. So
Yeah.
for almost first 6 months, we didn't hire anyone beyond the founding team. It was very hard because a lot of
Yeah.
people wanted remote,
Of
and
course.
people were not sure, and then there's a lot of changes happening in the economy itself. So yeah, it was not the best of times, but I think we pushed through it. I think we had, and thanks to the founding team, that we were able to stay strong.
Yeah.
And we also knew each other because most of us came from LinkedIn and Uber, so we
Yep.
worked together for a long
That has
time.
to
And
help.
those
Yeah.
those things helped a lot. So we didn't really have the need to meet on a daily basis to maintain that relationship. So that definitely played a big part.
Yeah, and it shows because in 2021, you got your Series A, and you had 18 people back then. So the growth, like you say, the growth wasn't huge to start with. But then
Yeah.
by 22, you've got Series B at 47 million,
Yeah.
and then you've got 150 people. So
Yeah.
within it seems like something just exploded. Like what?
Yeah.
I mean, that's a pretty big explosion. Did you get any anchor customers on board to drive that, or was it just an organic exponential sort of growth?
It's a combination of both. I think the first was definitely the organic explosion in terms of just the Pinot usage, because there were so many companies that suddenly got an idea of like, hey, this is something that allows us to do as something that we were not able to do before. I think that was the key thing because they were always ideas were never a problem. People had a lot of ideas of, hey, this is the product I want to build for my customers, be it internal or external, but they always lacked the technology, or if they had the technology, the cost was very high. I mean, think about everyone trying to build a who would my profile and they needed 1,000 node cluster, right? It's very
Yeah.
hard to justify a need for something like that. But now you have something that you can build, but it's cost effective, and it allows you to actually change the way you are serving your customers. I think that's kind of led to a lot of companies actually leveraging. We went from just LinkedIn and Uber to all the way to Walmart, Cisco, DoorDash, Stripe, all these companies. And especially people who are leading innovators, right? We are thinking
Yeah.
about constantly pushing the boundaries of, yeah, how do I do things that my others are actually not doing? And what happened is once we get the leaders adopting this technology, everyone else continue to follow that. So if you think about, for example, today in just the delivery and food and logistics area, you have like Uber, DoorDash, Cloud Kitchens, Zomato, Grab, Kareem. So many of these companies are actually leveraging these technologies.
Wow.
So someone ordering something today at any point of time is probably leveraging Pinot in one way or the other.
It's probably like the technology that a lot of people leverage and use but don't know exists in a
Yeah,
way, in that
yeah,
perspective.
yeah, yeah,
You're rattling off these names and they're all names that everyone knows very well.
yeah.
So that's really good. And talk about the setup. So how does people consume the platform? Hybrid and cloud deployment I know exists.
Mm-hmm.
The ingestion engine, like so that they connect it to their data source, then rips in the data, does all the analytics in real time on the platform, and then it spits it out. I've obviously made that very simple, but that's kind of an idea of what happens.
Yeah, yeah, in a way, yes. I think one of the key things that I want to highlight there is our goal was always to shorten the duration from event to insights. That means we had to analyze each and everything in between going from event to insight. And the first part was the ETL. And if you think about how ETL is doing, is generally you pull from one system, you do a bunch of things, and then you push it to another system.
Yeah.
And we were one of the first systems out there. We said like, hey, we shouldn't completely get rid of that ETL. So what this means is if you have some streaming systems like Kafka, Red Panda, Kinesis, or any of these, you don't need another system in between to pull the data from there and write it to Pinot. So we kind of embedded the ingestion into the system as a first-class citizen. So you just point at the source and you forget it, and we take care of everything in terms of ingesting. Now it makes the problem a lot harder because you now have to think about so many different things in terms of the formats, in terms of the sources, in terms of checkpoints and everything. But we took on that challenge in terms of solving that problem ourselves instead of transferring that problem back to the users, because then they spend a ton of money on ETL and doing all the processing. So it's kind of a push versus pull model, and we use the pull model so that you don't have to pay this additional cost, and also no need of the additional latency overhead that comes with it. And
Does that mean that
obviously,
it's
go
so I
ahead.
was going to say, does that mean that it's customized? Like when you have a customer that comes in, you look at their systems and then you then create that pool. Is that kind of how it works, or
It's not
is
it's not
it?
customized because it's pluggable. And what it means is there are very few systems that are actually that provide this, and we build connectors for all these systems. We have connector for
I was going to
Kafka.
say connectors. Yeah, okay, that
We
makes
have
sense.
connectors.
Yeah, the
Yeah, so
connectors
we
are in
use
play. Yeah,
connectors. Connectors are the ones that can be configured. So as new systems come, like let's say Kinesis or PubSub or Event Hub, we end up building those connectors. But you just build it
understand.
once for one of every main system that comes out there. But we do the hard work there in terms of making it easy for the end users.
That was the point I was trying. Yeah, so you guys are doing that work. Yeah, that's awesome. And you talked
Mm.
about ETL. ETL comes up a lot recently with regards to RAG, Retrieval-Augmented Generation, in terms of what that does with generative AI. So
Mm.
I think this sort of real-time data analytics, it lends itself to feeding, the beast that is LLMs and generative AI. So what have you seen in the last 12 to 24 months to have are you guys jumping on that bandwagon? Where is it being used? How do you see generative AI changing and enhancing, and maybe even pushing forward from an innovation point of view, the real-time analytics engine?
Yeah, we have seen quite a few use cases, and I think this is again a place where people are pushing it beyond what it's already capable of, right? And if you think about look at a lot of AI use cases right now, they're mostly on static data, right? I mean, you have
Mhm.
your documents, and they just indexes and turns them into embeddings, and then you search on those. But they're still in a very infancy stage, if you will, right? Because how many documents will you have? You probably have like hundreds of thousands maximum. But I think what a lot of companies our users and customers are doing is think about generating embeddings for your events, right? Every event that is happening today, it's a structured event, but imagine turning that into an embedding model, right? And that is actually something that people can actually use, and now they can actually search for a lot of different things related to that, and that allows them to build a lot of recommendation products. For example, like if you're looking for XYZ and you don't have that in the inventory, you can quickly check that you don't have that in the inventory and then show something that is actually related to that. So it's in a way, this is not just one system, but it's real-time analytics is becoming part of your agentic workflow as well, where you are looking at the data and then making the decision. You're not just building the model upfront and then every decision is just based on that whatever the model was trained on, but you have more and more new information that's actually available at the time of serving. So it's kind of leveraging that model that you built, but also leveraging the latest and greatest information that you have, and then mixing the two together and then providing the best experience for the user. So I think for us, this is just a beginning in terms of this is going to push the concurrency even higher, right? Because now we are no longer limited by people clicking on it. It's like agents are like constantly querying the system to actually make better decisions for you. So we feel that the need for higher concurrency and low latency is going to continue to keep growing exponentially in terms of based on the products that we see in the AI space.
Yeah, it makes sense. And we talked about, like earlier in the pre-show, we talked about the real-time RAG, or real-time retrieval-augmented generation. That's kind of what this becomes, right? And
yes,
in a sense,
exactly.
If we think about the example of going back to the start, LinkedIn, and then who's looked at your profile, that then to me, I go, well, okay, that's cool at that level for an individual, but then maybe some sort of retrieval augmented generation, LLM based generation of that at the next level. If you're a recruiter, if you're a manager, let's think, okay, how do you then look at your whole workforce, 1,000, 2,000 people, and get that information in milliseconds, right?
Absolutely.
Through that. Yeah. Tell me about my my accounting platform and my accounting users. Who's been looking at at their profiles? I think that's where it comes into play. It's really interesting. Anything else around that AI bit? Like, where do you see that going in terms of just in general, in terms of the data?
In general, there's a lot of there's a lot of directions that it's going in. But I think one other thing that we are excited is in the observability space.
Observability,
because Pinot is increasingly being used in logs, metrics, and traces as data as well. And if you kind of think about it, there is the way people are asking questions on the log is going to change, right? I mean, people are used to do all these complex queries, and they need to understand the semantics of how the log is structured. They need to do a awk and sed and grep and all these piping things. But imagine asking like, hey, tell me more about the slowest query that you saw between this time and this time. So that becomes a lot of natural language way of explaining that, and then its ability to actually tie different logs together with a common ID. So there is a lot of interesting models that you can actually build just for log data, for example. And similarly on the metrics, you can actually ask a lot of interesting questions instead of you going and looking at hundreds of dashboards and trying to come to a conclusion on the RCA, which is like the root cause analysis. You can basically say like, hey, this is what I'm seeing. I see this latency go up a lot. Can you just go and analyze all this data and tell me?
That's it.
I think that's where we are excited because these are things which are slightly different from your static models, right? Which is just built on documentation and built on knowledge. This is like combination of knowledge plus new information that's being available every second. And I think that's super exciting for us. And
that's awesome. Yeah, I think that's a really good use case. I've talked about this in a sense of observability and natural language observability, which I think this reduces, as someone who's historically had to look at dashboards and work out what's going on visually, and then you got to go down the rabbit hole of trying to work that out. If you can actually do that in real time through a natural language query, that's going to just make everyone's lives better, and we'll solve the problem of looking for problems, working out the problem, to actually being more efficient and more innovative. I think that's a really good use case. In 2 seconds, because we've only got a minute, I'm interested very quickly, what's the average data set that you guys work with in terms of customer? Like, are we talking petabytes, exabytes, like in a very quick time frame?
We talk about hundreds of terabytes. I mean, there are customers who go to the petabytes. The reason is we serve the highest value. So these might be smaller, but they have huge value in terms of what. So it's more important in what the way we look at is the number of queries. So we are serving billions of queries per week. So that's actually talks about the value.
That's how you do it. Yeah, awesome. Hey, it's been a great conversation. Like I said at the start, we could have talked for hours and hours on this. You guys have got a data summit coming up, and then the company's got so much growth, I think, and it's really an amazing story. I love everything. It started from computer games. We're talking about Yahoo, LinkedIn, and now you're just touching almost everyone who's ordering food around the world. So StarTree, it's a great story. Thank you so much for being on episode 97 of Great Things with Great Tech.
Thank you so much, Anthony, for having me on the show. It was a pleasure.
Hey, just as a reminder, thanks for listening to this episode. Stay tuned for more episodes where we continue to highlight companies and technologies shaping our world. Don't forget to follow us on social media at G2WGT Podcast and visit g2wgt.com for more great content and all past episodes. If you enjoyed this episode, make sure to subscribe on your favorite podcast platform and on YouTube. Please spread the word, and if you feel like it, drop a review. Thanks for joining us, and we'll see you next time on Great Things with Great Tech.